This is ThinkTech Hawaii. Community matters here. Okay, we're back. We're back. 1 o'clock rock. Research in Manoa with Pete Mouginis-Mark, a researcher, professor at the School of Ocean Earth Science and Technology, the Hawaii Institute of Geophysics and Planetology, and that can be put to music, by the way.
It can indeed.
Yes.
It's great to be on the other side of the table today,
Welcome
Jay.
to your show, Pete.
Welcome to my show. Thank you very much for being the host.
Absolutely. So today's a really special day. Originally, we set this up. You were going to be out on the mainland. You're going to be taking pictures and reporting back. Well, that would have been so terrific, about the eclipse today. So the first thing is, what is the eclipse today? What should we know about it? And secondly is, why aren't you there?
Well, first off, obviously the eclipse is an extremely rare event, Jay. I mean, we haven't had a total eclipse going across from the west coast to the east coast of the United States for over 100 years. We last saw a total eclipse here in Hawaii in July of 1991. Eclipses occur about every 18 months. So that it's an astronomical phenomenon, but it's rare for it to actually cover the United States. So that we can expect to see another one in Australia in late next year. But by and large, the whole concept of an eclipse is that the moon, as it orbits the Earth, occasionally, like every 18 months, goes directly in front of the sun. So that an eclipse is when the moon covers the illuminated disk of the sun, and its shadow falls upon the Earth, someplace in the Earth, often in the ocean, but sometimes on land as well. And today, August 21st, 2017, that shadow of the moon fell right across the United States over a period of about 3 hours.
So what's the difference between an eclipse, an 18-month eclipse, and a 100-year total eclipse?
They're exactly the same, depending on where you are on planet Earth. Primarily, today's eclipse is a really unusual time where it goes all the way across the continental United States. Yes, that is the unusual attribute. If you had seen the 1991 eclipse in Hawaii, it would have been almost identical to today, except you had been in Hawaii.
So one more thing that strikes me, though, is that are these eclipses, Peter, are these eclipses always the same, or are they different? You as a scientist, do you look for changes from one eclipse to another?
By and large, they will be very similar, but they provide unique opportunities for scientists to go and measure various attributes. And of course, over the years, the instrumentation improves so that they're discovering new things.
So you find out more each time because you have different instruments and different measurements and so forth.
And today, there are a whole suite of different measurements being made, whether looking at, say, how it affects radio signals, like from GPS, the Global Positioning System of satellites, or whether it's AM radio communications, because you suddenly change the temperature of the ionosphere, the upmost layer of the atmosphere, or whether you're actually trying to find various elements in the outer part of the sun's atmosphere, the coronosphere.
That takes me to the title of the show, Chasing the Corona.
Chasing the Corona.
It's not beer. We're not talking about beer here.
We could do that as well as celebrate the lunar eclipse.
Spelled the same way, by the way.
Spelled the same way. Thank you very much.
So you're not chasing it, though. You're here.
And
you stayed home. What happened?
Well, let's go to the first slide, first of all, Jay. And what we'll see is that we could actually see a little bit of the eclipse. I live back of Makiki here in Honolulu. And what we're seeing here is a diagram of the Hawaiian Islands. And those little yellow discs, that actually represents the sun. And at various parts across the state, you can see Honolulu at 27.3%. That's how much of the sun's disk was covered at about 5 minutes to 7 this morning. Of course, it was completely cloudy where I lived, so I didn't see it at all. We're at a northern latitude, so that if you're going down towards Nanalehu on the Big Island, you would only have seen about 19% of the sun's disk.
Makes a difference.
It makes a huge difference. And the key thing is the difference between 99% and 100% coverage. I really wanted to be there in Oregon. My family was getting really excited about it, and then we started to hear, middle of last week, the fact that there might be more than 1 million people driving into Central Oregon to see this eclipse, and it turned out that the concern about the traffic, as well as a number of brush fires, was just proving too much for some of my in-laws, and quite honestly for myself and my wife as well. So we decided to stay here and enjoy the eclipse vicariously through the NASA website. It's not the same.
Yeah, well, and those million people, if they were better advised, you know, they would just watch ThinkTechHawaii.com.
Indeed, they're wasting their time seeing a celestial phenomenon when they could be watching ThinkTech. Yes, yes, yes.
So did you make that graphic we just saw? Who made that?
No, these are NASA graphics.
NASA.
So all of the images which we'll see today are either from NASA. There's one from my son-in-law where we'll see what the crowd is like around Madras in Oregon and that sort of thing.
So is it fair to say we love NASA? I mean, NASA provides us all these great images.
I'm a space cadet, but NASA apparently was getting 87% of the total internet traffic during the eclipse. So, sorry, federal internet traffic, not all of the internet, of course, but there were many instances where we were watching at the university earlier this morning, and the video connection went down simply because the load on the internet was so great. So yeah, it's really impressive. NASA does a fabulous job, not only keeping the community informed about just some of these events, which are like the eclipse, or say the launch of a rocket or the International Space Station, that sort of thing, but also public outreach, education, STEM education, science, technology, engineering, and math. They really are on the ball in terms of that.
And they put it in public domain, which means anybody can use it, which is very, very nice of them and helpful.
And everything's streaming live now. We'll see later on in the show, we even had images from the International Space Station, and they had live video from NASA high-altitude airplanes. They were also launching balloons up to about 100,000 feet to look down on the Earth's shadow, for example. And all of this they're providing free in real time. So if anything went wrong, the audience gets to see that it's going wrong. So, there's this transparency, there's this excitement, and you can see from like all of the crowds on the ground, this is a really spectacular event sort of thing.
Now, you said a minute ago there's a 100% time. It's 100% time when the moon is blocking out, what, the whole sun?
Correct.
Does it ever actually block out no corona at all?
Well, we'll see the corona when the moon covers the complete disk of the sun.
It's still a corona, even though it's blocking out the sun.
Let's go to the second slide, and what we'll see is that we've got a map here of Oregon, which is on the west coast of the United States, and running sort of 2/3 up through the state, you've got these sort of gray elongate objects. That is the shadow of the moon, and the path goes from west to east, and it goes west to east, not east to west like the sun rises in the east. In this case, the moon is orbiting the Earth faster than the Earth is rotating, so the moon's catching us up. And what we can see here is just for Oregon, and the first time when the sun's disk is totally covered was at 10:18 in the morning Pacific time, and then as it goes into Idaho, it was probably about another 15 minutes. So I brought along a video. If we could show the video first of all. Next, what we'll see as we run through this NASA-produced video, it's not a circular dark shadow. As we see on the video, what we'll actually find is, and here we're starting now, so this is a simulation. This is not from space. Here's the shadow of the moon just going through Lincoln City, coast of Oregon. And as we watch this, so we've gone through Madras, where my stepdaughter is right now, she was there, and then as we go across Idaho, and then we're starting to get into Wyoming, pay particular attention, that dark patch, notice that it's not circular, it's egg-shaped, and it's going to be going, basically, it's egg-shaped line sort of top left to bottom right. But as we get across Wyoming, Idaho Falls just coming through here, it's going to start rotating. That's because you're projecting the shadow of almost a sphere onto another sphere. In other words, that's the Earth. We're going through Wyoming. Now it's starting to look much better in terms of shape. Casper, Wyoming's enjoying it now. And this is playing out over a time period of about 2.5 hours.
So this is a little faster than the actual speed it would be making.
Correct. I thought that the viewers would get bored if they watched it for 2.5 hours. But as you go through, clearly, you have to start worrying about weather conditions, and particularly as we get to the East Coast today, around about lunchtime in South Carolina, it was still cloudy. So that viewing, this is the ideal situation. But in many instances, there are either high altitude clouds or complete cloud cover earlier on. But now you can see it's almost circular, so that the moon shadow is falling almost directly onto the Earth's disk. And then as we're coming through, there's Kansas City, we're going through Missouri, and then as we approach the East Coast, we'll actually start seeing it's rotating more and more. So it's gone from sort of top left to bottom right. Now it's almost top right to bottom left. And that's just the consequence of the shadow of the moon being projected onto a spherical Earth, that sort of thing.
So if I'm off the path, and close to it, I can still see a partial ellipse.
Yes,
eclipse.
but it's not the same. It really isn't. You had to be within this path of totality in order to see any of the spectacular aspects of the eclipse. That even if you're just sort of like 10 miles outside this brown or dark gray area, it really
not the same.
They said on the radio today, it's like driving 95% towards Disneyland. Do you enjoy Disneyland from 10 miles away? Not as much as if you're there. So you've really got to be in the path of totality. And here we're coming up to Charleston.
We've crossed the country.
We've crossed the country. It's now like 2.5 hours since Oregon. Here today it was cloudy, but that was really quite unfortunate. And so before we go to the break, let's just take a look, if we can stop the video, look at one other slide, because one of the things which we've only recently discovered through one of NASA's satellites orbiting the moon is that the moon is not a perfect sphere. And if we look at the topography of the moon in detail, we'll see in this particular diagram, so the image in the middle, that's the near side of the moon, which we always look at, and that blue squiggly line running around it, greatly enhanced, is a diagram or trace around the topography of the moon. So there are valleys on the moon as well as mountains on the moon, and so the low points where on the left-hand side, for example, the valley is almost touching the rim of the moon, that's a real low point.
But this tells us that when we look at the inner circle here, that's not the whole moon.
Well, it tells us that the moon has mountains and valleys like the Earth does, whereas if we stare at it from the Earth with a telescope, we really don't have that much of an impression.
Why is that line blue? Because I have always suspected that it's blue cheese. It's not only cheese, but blue cheese, and that's why they use blue on the line?
We have this image simply because when people were looking at the total eclipse, they're like diamond ring effect, as it's called, or there's a ring of pearls. That's where the sun is actually peering through or over the horizon on the moon. So that blue line is totally imaginary. It's just a rendition of what the ups and downs are as you go around the moon. But it tells us something about why we see these, occasionally we see the diamond ring and the ring of pearl phenomena in a total eclipse, because the moon isn't perfectly smooth and it's not perfectly spherical.
We learn something every minute.
Well, that's the whole point of the show, right?
Of course, every show.
Yep.
Pete Mouginis-Mark, researcher, professor at HIGP, the Hawaii Institute of Geophysics and Planetology, part of SOEST at UH Manoa, here on Research in Manoa, studying the eclipse happening right now on the mainland. Whoa, wow. We can take a minute, to get our heads together. We'll come back. We'll see more slides, more pictures. We'll learn more about what's going on. We'll be right back. This is ThinkTech Hawaii, raising public awareness.
Ted Ralston here, folks, your host on Where the Drone Leads, our weekly show at noon on Thursdays here on ThinkTech, where we talk about drones, anything to do about drones, remotely piloted aircraft, unmanned air systems, whatever you want to call them, emerging into Hawaii's economy, educational framework, and our public life. We talk about things associated with the use, the misuse, technology, engineering, legislation, with local experts as well as people from across the country. Please join us noon on Thursdays and catch the latest on what's taking place in the world of drones that might affect you.
Hello everyone, I'm DeSoto Brown, the co-host of Human Humane Architecture, which is seen on ThinkTech Hawaii every other Tuesday at 4 p.m. And with the show's host, Martin Despang, we discuss architecture here in the Hawaiian Islands and how it not only affects the way we live, but other aspects of our life, not only here in Hawaii, but internationally as well. So join us for Human Humane Architecture every other Tuesday at 4 p.m. on ThinkTech Hawaii.
We're back. We're ready. We're ready for the eclipse. I cannot see the camera that I'm supposed to be talking to.
But we're too late, Jay. We are too late. But anyway, so these are the glasses that one would normally wear looking at the sun.
Yeah.
But these are absolutely vital. Eye safety is paramount when you're watching.
So this is 50 cents on Amazon.
50 cents on Amazon.
$50 if you get scalped.
And if you get scalped, it's $50, yes. But anyway, so we didn't actually see any of the images from today's eclipse. So if we go to the next slide, this is a NASA image. So what we're seeing here, that orangey crescent is about 30 seconds before the moon went completely in front of the sun at Madras. And I know because I've had communication with my stepdaughter and my son-in-law. If we go to the next slide.
Which get that from this slide?
This is NASA, and here is my stepdaughter.
Okay.
And apparently she's in a mobile traffic jam right now. My planning in not going to watch the eclipse in person paid off because the traffic is absolutely horrendous.
I'm sure.
Not only vehicular traffic, cars, but also airplane traffic is just totally chaotic. Here she is at Madras Municipal Airport, for example, staring up at the sun. But she got a wonderful view, just over 2 minutes of totality. In totality, in the next slide, we can actually see kind of what it looks like. In the next slide, what we're seeing. Next slide.
Okay, that's the moment of truth.
This is the moment of truth, or 2 minutes of truth, basically. And everybody on the TV today was sort of totally in awe, and this is an ethereal experience, not only because only in a total eclipse can you see the upper part of the sun's atmosphere, but also some of the planets came out. People were saying they could see Venus, they could see Mars, they could see Jupiter, because the sky during totality is virtually as dark as it is during nighttime. So this is a rare opportunity. All of the animals, the birds went back to sleep, the crickets came out, and so unbelievable. The temperature drops. When I was on the Big Island for the 91 eclipse, the temperature drops, and it's just an amazing feeling. It's like an experience unlike anything else I've had.
We need the sun. We rely on the sun. We're dependent on the sun every minute.
And just that human thought process, something is odd, something unusual is happening.
You can imagine, Pete, back in the day of the clan of the Bear Cave, in prehistoric times, you can imagine what people thought.
But you see, this is why civilizations like the Aztecs or the Mayans valued astronomy so much, because this is an oddity happening in the sky, and if the leader, the king or the ruler, wasn't able to reassure the population that something drastic is happening, they were in trouble. So amazingly, all of these sort of early civilizations managed to figure out not only when the eclipses was going to occur, but they knew enough about astronomy that they could actually say where on planet Earth they would be occurring as well. So it's really a very impressive feat.
Well, I think it was probably important for the leaders, whoever they were, to be able to explain, as you said, and even predict, and that puts them in a position of leadership.
That's right. If they know what is going to happen in the heavens, then they must be
They got it under
right
control.
on. Yeah. Let's take another look at a slide. And this one, we mentioned earlier the great job that NASA does with all of this public education. They were live streaming from about half a dozen places across the continental United States. I don't know any of the people here, but they had astronauts, they had scientists whose speciality is studying the sun. They have people who are on board aircraft making detailed measurements of the atmosphere of the sun, and that's important because only then can you actually infer what the composition of the outer part
Because otherwise you
of the sun
can't see it really well.
because you can't see it very well and that sort of thing. And there were also some really fun things. The next slide, I think, will show. For example, you can recognize sunspots. This one it is an image, I think, from Idaho. And what we're seeing here is the disk of the sun. That's the bright bit. The limb of the moon is the dark chunk taken out on the left-hand side, and you can see some sunspots. But the one which I really thought was really fascinating in the next slide, what we'll see, this is essentially a time-lapse set of images, okay? And what you can see running from sort of, you're primarily looking at the disk of the sun. The moon is in the top right, so that's the chunk taken out of the sun. And then you can see just a few little dots running from left to right across the center.
Yeah.
That is a time-lapse series of photographs, all superimposed one on top of another. Any guesses what that is?
What is that?
That is the International Space Station.
As it's crossing the heavens.
As it crosses the heavens, they stationed a camera on the ground exactly where it had to be to look at the sun during the eclipse and see the space station going in front of it.
Oh,
So
wow.
there were views not only of the space station from Earth, but also looking from the space station down on the Earth. And all this was live. I mean, it was absolutely incredible that, you know, the technology today where you can live stream, they were asking the astronauts, well, what did you see? You know, how dark is the shadow? And you know, there were people on the ground who'd flown in space and watching the eclipse on the ground, and there were people in orbit today looking down on the Earth. Absolutely incredible, the logistics effort which NASA put in to just bring to the general public all of this, you know, fascinating video and the excitement. You know, this, in my mind, they did not spend enough time talking to the average person who had perhaps driven hundreds of miles to attend today's event. You could tell from the shouts in the background when totality came across a particular, everybody was ecstatic, and you know, I think NASA could have spent even more time just pointing out to the community how exciting this kind of free show really is.
Well, it sounds like it brings people together.
Yeah.
It has an effect on the country. I mean, or at least the people nearby, and it sends a message. They send a message, namely that science is good. We believe in science. We believe in astronomy. We believe in geophysics. And at a time when there are certain people, and I won't mention their names here on the show for feeling of contaminating the show, certain people who don't believe in climate change, and thus they don't believe in science.
And the backstory to today's event is that NASA's been telling everybody about, you know, exactly to the millisecond when the eclipse is going to be occurring various places across the continental United States, and they could only have done that, you know, without good mathematical computer models, all of these generated images which we've been seeing. It's clear that, you know, at some point science and the way that it's conveyed to the general public, this event today is a really great example of NASA at its finest. But you know, just keep pushing ahead, you know, telling high school kids why they need to study physics or math or chemistry, because here's a sort of a day-to-day example of what they're seeing, sort of thing.
Yeah, it's symbolic.
Yeah,
And it happens, it comes at the right time.
It's really good.
Do you think it was intended this way? Maybe so.
Oh, we've known about this
Yeah.
eclipse. For example, my wife and I are already starting to look, well, what are the future eclipses coming up through about 2040? And as I said, there's one every 18 months. There's one in Antarctica. The next one to come to the continental United States is in March of 2024, for example. Where do you want to be ready to see this? And the science behind both tracking the orbit of the moon and Earth's rotation, it's now down pat in terms of what exactly we could expect to see, sort of thing. Let's take just another. We've got one or two other images. I mentioned, for example, we've got the space station. Here is a diagram showing the orbit of the space station, and that's in red. So we're looking at North America on the Earth's globe, South America down at the bottom. ISS is the International Space Station, so that its orbit did pass through the eclipse. And the last image will actually show us what the astronauts on board the space station could actually see. If we look at the next slide, this is a view today from the space station. All right, so they're orbiting at an altitude of about 320 kilometers, or give or take 270 miles above the Earth's surface. They can beam down to Earth, they radio digital images, and we're looking at the limb of the Earth, clouds, the white things in the foreground, the clouds, but notice just below the horizon there's this dark patch. Unfortunately, the space station did not fly directly through the area of totality.
The shadow, yeah.
The shadow. But there's this general area, the gray area.
Tell me again where that is on this graphic. Where is that dark spot?
The dark spot, you can sort of see a bright blue curved line just below the NASA meatball logo, near the top of the image, all the way across the image. And then in the center of the field of view where you've got that dark patch, that's not nighttime, that's the shadow of the eclipse on the clouds over North America.
Yes, that's really interesting.
And so it's like the picture of the Earth that the Apollo 8 astronauts took back in December of '68, for example. Looking at the Earth, it provides one a whole new perspective on our place in the universe. There's this excitement about understanding the way the Earth works with climate change. There's excitement about how we put the Earth into its perspective within our solar system. And then, of course, the real new frontier for scientists is that we've got all of these other stars with planets orbiting them as well, and trying to speculate, is Earth unique in terms of being able to experience a total eclipse? Or are there other places somewhere in the universe where you've got what are called exoplanets, which means planets around other stars in our universe? Who knows?
It affirms a lot of things. We see the things we've been sort of theorizing about, and then it also raises questions, as you just mentioned. But one thing of interest to me is the measurements, the instruments you mentioned early on in this discussion, because now we can make more careful measurements of what's going on. What kinds of things can we learn with these new and more accurate measurements?
Certainly the composition of the sun. Institute for Astronomy here in Hawaii is one of the leaders in terms of building what are called spectrographs, which will give us very precise measurements of the chemical composition of the outer part, the corona of the sun. So that's one thing. Then we start understanding things like, how does solar radiation affect the Earth? The GPS signals coming through Earth's atmosphere will change as they pass through the shadow of the moon before they reach the Earth. And so that gives us a handle on how, say, solar radiation might actually be affecting all of the electronics that we have here on the Earth, whether it's the power grid, whether it's your laptop computer, or anything. we have to understand that we on Earth live in the environment created by our sun, which is basically a common or garden, a star. But the sun's atmosphere extends way beyond Earth. So we are living in the sun's atmosphere. It's just very, very thin.
Yes.
But by looking at an eclipse, such as the one we had today, we get to see in detail what is like very close to the surface of the sun. And NASA, for example, is going to be sending, in the next couple of years, a spacecraft to fly way, way closer to the sun
That'll be
than the
autonomous,
planet.
won't it?
Yeah, oh yeah, but closer than the planet Mercury, the sun. So there's real value in studying the sun, what's called space weather in terms of the radiation coming off of the sun, and the composition of the star and that sort of thing.
So we saw the path going into the Atlantic from, what is it, North Carolina?
South Carolina, yeah.
South Carolina. Has that happened already?
Oh,
Is
yes,
it
it's
over?
way gone.
It's over.
Way
gone.
It was way gone by about 10:30 Hawaii Standard
a few
Time
hours
this morning.
ago.
A few hours
So
ago.
when's the next one coming? When should I plan to be
As
around?
I said, March of 2024. It starts off over Mexico, goes across the Gulf of Mexico, so it probably comes ashore. I forget if it's Texas or Louisiana, and then it goes up and it finally crosses the New England states.
You're going to hold on to those glasses because maybe you will get to the mainland on that one?
Or try and get to one of the other ones between then and now. I think there's 3 before that next eclipse in 2024.
So Pete, you are the true host of the Research in Manoa here on Monday at 1 o'clock. And I wonder if you'd close the show for me and tell them what you'd like them to keep in mind, or what message you want them to hold on to.
Well, let me just remind the viewers, you are watching ThinkTech Hawaii Research in Manoa. I'm your guest or host, Pete Mouginis-Mark. And to follow up on Jay's comment, yes, today's solar eclipse is one of the most stunning solar events that you'd ever get to see. It's nature at its finest. It's ethereal, spectacular, enthuses the entire population. Scientifically, we learn an awful lot about the sun and how the sun's atmosphere infects the Earth's atmosphere, but primarily it's just a way of demonstrating the value of science research, engaging the community in terms of physics, math, getting the youngsters to really study hard. So it's a wonderful event, Jay. We've really seen a lot of NASA at its finest. Obviously, they didn't stage the eclipse today, but nevertheless, it's a really good demonstration of how science can be brought to the general public. Thank you, Pete. Pete Mouginis-Mark of HIGP, talking about chasing the corona today. And right after this show, we're gonna do that. Thank you very much, Jay. Thank you so much, Pete. Thank you for being host today. Absolutely. Aloha. Great fun.